So task one is to find the mutual friends in the Facebook for two people using MapReduce in Spark. These are Python code. Here initially we are calling the run method with the input file and the output file. Input file contains the Facebook friends for each person, and the output file we are storing the mutual friends output. In this run method, initially we are reading the text file, that is the input file, and it returns the RDD, which is a list of strings, and we are calling the map function map friends on these lines. What the map friends does is it takes each line, splits by the space, and groups the person and the friend. That is, for 01 it returns 0, 1. For 02 it returns 02. This is what the map friend does. And on the map friends output we are grouping by key, that is our output will be 0 comma the list of friends for the 0, so 0 comma 1 2 3 the entire list. That is stored in map to friends. On the map to friends we are calling again a map to group. Here map to group takes the person and the list of persons and returns the output as a key containing two friends and the value containing the list of friends. That is, it returns 0, 1 and the value as list of all the friends for the 0. Similarly, 02 as a key and list of friends of 0. That will be the output of map to group. And on map to group, we are then calling the reduce by key. The reduce by key, it just takes the common key, that is 01 and 01, and friends of 0, intersection of friends of 0 and intersection of friends of 1. This will give us the mutual friends. This is stored in the mutual friends, and then we are saving the mutual friends to the output text file. Now let's run this program. So here you can see the output folder Facebook mutual friends is created. Let's see the output part 0. Yeah, this is the output. Here 0 10 has mutual friends 0 13 3, and yeah.
To task 2, we need to perform 10 queries on the chosen data set, and using 5 queries, we need to compare between the RDDs and the data frames. And every query should be unique from the other queries. Now let us look into the code of the task 2. The dataset that we are using is FIFA World Cup, and it has 3 CSV files. The World Cup has the data about the winner, runner-up, and countries in which the matches were played for each year. And the dataset World Cup matches has the data about the each match of each year, whether it was a group 1 match or semi-final or finale match, and what were the home teams and what were the away team names, and home team goals and away team goals and team initials, etc. It mainly consists data about the matches. And moving on to the next data set, World Cup players. In this data set, there is has data about each player, whether the player is goalkeeper or captain, and player played for which matches, which is there in match ID, and the team initial of the team that the player played for, and the shirt number, etc. Now let us look into the queries that we have performed. Initially, we loaded the 3 CSV files into df1, df2, and df3, and then we are printing the schema which prints the attributes of each data frame. And then we are creating temporary views out of these data frames, that is WC, which has the World Cup .csv file, and players, which consists data about players, and matches, which has details about matches. The first query that we are performing is which team won the highest number of times. For that, we are displaying the winner and a count of star as highest count from World Cup, and we are grouping by the winner, so that we are grouping by the winner team, and then we are counting the number of times the records are there in the grouped function, and then we are ordering by count of descending, so that we would get the team which won the highest number of times. Moving on to the next query, we want to find which year there was maximum attendance for the games. So for that, we are finding out the year and attendance, and then we are ordering by attendance descending. So we would be getting in the descending order. The next query is we want to display the home team goals and away team goals for each stage. So I'm displaying stage and sum of all home team goals for that stage and sum of all away team goals for that stage, and I'm grouping over here by stage. The next query is that I want to find out the referees who participated in most number of matches. So I'm displaying referee and the count of matches for that that referee has participated in, and I'm grouping by referee, so that I want to count the number of records he was there in, and then I'm ordering by count and limiting only 5. So I want to display the top 5 referees. Moving on to the next query, I want to display the home team goals for the winners, the number of home team goals for the winners. So over here I'm joining the data sets, tables, matches, and WC. And the joining condition is that the home team name should be equal to the winner, and I want to group by the year. So for each year and winner, so for each year I would be getting only one winner, and I want to order by year. So I'm finding out the sum of home team goals for that winner, and I'm displaying the year, winner, and the home team goals. Moving on to the next query, I want to find the countries that hosted the highest World Cup matches. So initially I'm selecting the country and the count of country from World Cup. Then I'm grouping by the country, so that I would be getting all the records of the country, and I'm ordering by count descending. So I would be getting the highest hosted highest World Cup matches. The next query, I want to find out the number of matches in year 1934 and in this stadium. So this query is simple. I'm doing count of star, and in the where condition I'm giving year 1934 and stadium name. I'm giving the stadium name. Moving on to the next query. In this query, I'm joining the matches on players. I want to find out the captains of all the finale matches for each year. For each year in the finale match, I want to find out the captains. So I'm displaying the year and the player name. I'm joining the matches table on players table with matches.stage as final, since I want to find out about the final match, and player match ID with the matches match ID, and the players.position should be C, which implies captain. Moving on to the next query, I want to find out the referee, count the number of matches of the referee Messias Jose. So over here I'm giving count of star with where condition referee like name percentile. And moving on to the next query, I want to find out the stadium with highest number of matches. So I'm selecting stadium, grouping by stadium, order by count of star, and limit 1. I want to display only one record. Moving on to the last query, I want to display all the goalkeepers. So I'm selecting the player names from players where position is GK. These are the 10 queries, and now I would like to compare the RDDs with the data frames. I'm loading the CSV file into CSV, only the World Cup CSV, and then data as data without the header, without the first header. And then for each data, I would like to split with comma and collect. And the first RDD that I want to do is I want to find out the winner of 9:30. So in the RDD, in the data, I'm filtering with, I'm first splitting the records with comma, and the first column with over here I'm given index as 0. I want to compare it with the value should be 9:30. If the value is 9:30, then for those records I'm getting the columns, displaying the columns 0, 1 and 2, which is year, country and winner. And similarly in data frame dot select, I'm doing the year, country and winner, and the filter condition I'm given over here is year equal to 1930. And in Spark SQL, it is select year, country, winner from WC where year equal to 1930. And moving on to the next query, I want to find out the years in which Uruguay won. So over here, I'm filtering the column 2, since this is a winner column with this country name. And then I want to display the columns year and winner, and the next column, third, fourth columns. Similarly, I'm displaying year, winner, runner-up, third, fourth, where winner equal to this country. And this is a query in Spark SQL. Moving on to the next RDD, it is I want to get the attendance greater than 500.0. So I'm filtering the attendance is 9th column, starting from 0 index. So 9 greater than 500.00, and I want to display the columns year, which is 0, and country, which is 1. Similarly, select year, comma, country where attendance greater than the value, and select off the query. Moving on to the next RDD, I want to find out the records in which the hosted country is the winner. So I'm comparing it with the, since country is of index 1 and the winner is of country index 2, I'm equating this both, and I want to display the year and country and winner. Similarly, year, country, winner I want to display, and I want to filter with country equal to winner, and this is the Spark SQL query. Moving on to the last RDD, it is I want to display the records in which USA was either winner or the runner-up or the third or fourth, either the winner or the runner-up or in the third or fourth position. So over here I'm filtering the data with the column 2, which is the winner equal to USA, or runner-up, which is column 3 equal to USA, or third, which is called index 4 equal to USA, and fourth, which is index 5 equal to USA. For all those, I'm displaying the year, winner, runner-up, and third and fourth. Similarly, I wrote the filter condition over here: winner equal to USA, or runner-up equal to USA, or third equal to USA, or fourth equal to USA, and I'm displaying. And over here, this is a Spark query. So over here I'm displaying the year, country, winner, runner-up, third, fourth from WC, where winner equal to USA, or runner-up or third or fourth equal to USA. Now let me run this queries. So this is the structure of the World Cup table, worldcup.csv. This is about the matches CSV, and this is about the players CSV. Then this is the first query. We have found out the winner, which was winner for most number of times. Brazil was winner for maximum number of times, and this was the next query where the attendance was maximum for year 1962. And moving on to the next queries, for each stage the sum of the home team goals and the sum of the away team goals for each stage. Moving on to the next query, referee with number of matches played. And moving on to the next query, we want to find out the winner with number of home team goals, and for this we have joined the winner World Cup table and the matches table. And moving on to the next query, for each country we want to find out how many times it has hosted. And the following query was, let me just check, what was I? Yeah, where the year was 1935 and the stadium was particular stadium. And then next for finale, the captains of the finale. So in 1930, these players were the captains, and 1938, the captains were these players, etc. for each year. And the number of matches for which the referee was the Macias Jose. And moving on to the next query, it was the stadium, and I was counting it. And the next query was for each goalkeeper players, and this is the RDD's data. And the first query was the year 1930. I want to display the year, country, and the winner. And the second one was the second RDD 2. I was filtering with Uruguay. So this is the data displayed over here with winner Uruguay, as we can see, and the runner-up, third and fourth players too are displayed over here. And the next query was attendance greater than 500.00, and the output is over here. And the next query was country equal to winner, and the data is given over here. And the last query is about where USA was in runner-up, winner, or third or fourth position, and the data is over here. This is all about the task 2. Moving on to the next task, task 4. In the task 4, we want to perform the page rank. Page rank specifically finds out the importance of each page depending upon the weight of its edges. So the data set that we are using for the page rank is meta groups, in which it has details about each group, and these would be the vertices of our graph, and group edges, the edges between the various groups, and the weight of the edges, which would be the edges of our graph. And moving on to our task, we are initially loading the group edges, which is the edges into edges underscore df, and meta groups, which are the vertices into groups underscore df. We are printing the schemas, and we are creating temporary views E and G, which represents edges and groups. And we are running the select star from each of the table. Vertices is nothing but the groups, so we are taking the G1 value, and then we are replacing the column, renaming the column group ID as ID, and we are taking only 100 records. And E1 is, and that too we are taking the distinct records, and edges in, so we are taking E1 and we are renaming the column group 1 vertex as source and group 2 vertex as destination, and we are limiting it to 500 and distinct. So we are creating a graph with vertices and edges, and the first thing we want to find out is the total number of vertices count and the total number of edges count. And the next thing we want to find out is the page rank. So we have given a graph, and on the graph we are calling the page rank and a reset probability with a 0.15 till when the change is less than 0.15 we would be stopping it. Tolerance is 0.01, we would be stopping it. And to from where to start the random walk, which vertex we can randomly select with reset probability 0.15. And when the change in the value from previous iteration is less than 0.01, we would be stopping the PageRank algorithm. So we are running the PageRank algorithm on the graph, and we are storing the result in station PageRank. So we are after that we are displaying the results of the vertices and the edges. Let me just run this task 4. As you can see, this is the structure of the edges table, and this is the structure of the vertices table, which is group meta groups, and the edges is nothing but group edges. And this is the data from each of the table, and this is the data from edges table, and this is the data from the vertices table, where we have renamed the columns of ID and source and destination. And the total number of vertices count we got is 100 since we limited it to 100, and the total number of edges count we got is 500 since we limited it to 500. And this is the page rank, final page rank, and this group has the highest page rank, and following by these groups, and this page rank is determined based on the edges weight, and which is displayed over here. This is all about task 4.
Task 3, performing the word count on Twitter data using the Spark streaming. Here we have two Python programs, twitter.py and twitterstreaming.py. In the twitter.py, we are basically collecting the data from the Twitter using the Twitter streaming API and sending the data over the socket continuously. Now the data sent over the socket at a particular port is read in the Twitter streaming API, streaming Python file using the Spark streaming. Now let's go to the code. In the twitter.py, we are importing from TweePy our necessary classes. We have the authorization tokens for the Twitter API from the Twitter developer account. Here first initially we have a socket here, and the host and port number we have given as 6000. We are binding the socket to this particular host and port number, and we are listening at this particular port. Now when a connection is requested at this particular port, we are accepting that particular connection, and we are reading data to the socket. Here in the read data, we are basically connecting using the Twitter streaming API and collecting the data. Here we are only collecting the data for the tags, layoffs, COVID, corona, and work from home tags. So when the data is read from the Twitter streaming API, we are converting the data into JSON format. Since each Twitter data has so many parameters, we are only collecting the actual text of the Twitter data, and then we are sending the text data over the socket. Now in the Twitter streaming API, here we are collecting connecting to the particular socket at port 6000 using socket text stream. Now when the lines are read, each line is read 2 lines. Now to perform the word count, we are splitting the line with the space so that we get all the words. And in the mapper function, we are mapping each word with 1. And in the reducer function, for each key, we are doing the sum. Maybe with the same word, it will give 1 plus 1, 2. So that's how we are performing the word count. Now let's run this particular file, run Twitter. Now you can see the Twitter socket is created and is listening at the port 6000. So when we run the Twitter streaming py, it basically requests at port 6000, and this particular port accepts the connection. Now let's run this file. Now you can see it accepted the connection from 1 to 7 from the local host. Basically here this is the Twitter data being read. Now the Twitter data is sent over the socket at the port 6000. The Twitter streaming basically reads the data and performs the word count. Well, here you can see the output from the Twitter streaming, the word count. Here you can see schools count 1. Here you have COVID-19 with count 4. This is all about this ICP.